Hi everyone, my name is Yihan Lin and I'm gonna do the question 1 of homework 4. So let's begin. So the problem gives us that y equals to gx equals to these four terms when x is equals to different values. So apparently we can derive the range of y. It is from -1 to 0 and 2. So we want to find the density function and the distribution function of y. So we can first find the density function. So the density function when y equals to -1, apparently when y equals to -1 when x is larger than 2. So the fy -1, it equals to the probability of x is larger than 2. So it equals to 1 minus the probability of x is less than or equal to 2, and it is equal to 1 minus the distribution function of x2. And then we find when the y is larger than 0 and less than 1, we can just use the fundamental theorem to find the density function of y. It is equal to fxx divided by the derivative of gx and with the absolute value. So it equals to fx 1 minus y divided by 1. The absolute value of -1 is actually 1. So it just equals to fx 1 minus y. And the density function when y is equal to 0, it equals to apparently is equal to the y is equal to 0 when x is larger or equal to 0 and smaller than 1. So it's the probability of x larger than or equal to 0 and smaller than 1. So it equals to the distribution function when x equals to 1 minus the distribution function when x equals to 0. And we use the same thought. So when the density function when y is equal to 2, it equals to the when x is less than 0. So it's equals to probability of x is less than 0. So it just equals to fx0. So that's the density function of y, and we can write them in like in a conclusion term. And that's the figure of it. We can just simply what we should notice is that when y is equal to -1, when y equals to 0, and when y equals to 2, it's just the three impulse function like this. And when y is larger than 0 and less than 1 is this part. So this is the figure of the density function of y. And then we can find the distribution function of y. So apparently when y is less than -1, it is just equals to 0. And when y is larger or equal to -1 and smaller than 0, we can use the definition of distribution function. It's just integral of from -infinite to y, and the fy alpha d alpha, and we can just substitute the fy alpha into fx with the conclusion we draw from the density function into it. So it's equal to this term, and we can separate into two parts. The first part is the integral from -infinite to -1, and the second part is the integral from -1 to y. And the first part is just equals to 1 minus fx2 because it's just equals to the y equals to -1. This impulse function, and the integer is just the area, so it's equal to 1 minus fx2. And the second part we can derive it is this term, and it equals to 1 minus fx 1 minus y. And for y is larger and or less, larger or equal to 0 and smaller than 2, we still use the definition of it, and we still separate into two parts. The first part is the is the minus infinite to 0. The second part is 0 to y, and still use this impulse function, and we use the area of it, so it's equal to 1 minus fx1, and the second part is fx1 minus fx0, so we it derives to we can have 1 minus fx0 eventually, and for y is larger or equal to 2, simply we just have the distribution function equals to y. So in conclusion, we have the distribution function equals to 4 parts when y equals to different values, and we can draw this function like this, just separated different intervals, so we can have this kind of figure. And that's all for the question 1 of homework 4. Thank you.